So starting with the capsule, right? Well, actually, the big heading here would not be really the capsule, would be the, right, the collective one is glycocalyx. So real quick, you have glycocalyx, which can be loose, right, or rigid. If it's loose, it's really a slime layer per se. If it's organized and rigid, it's called the capsule. So what are important things to remember about the capsule function-wise? Right? What are some of the, it's used for attachment. What would be an example? We talked about this in this chapter and then also in chapter 20 or whatever, medical microbiology. Strep mutant, so that would be another concept you have to remember. Strep mutant, this is the one that causes what? Dental caries. Exactly. So anything that I'm writing could easily be part or a full question. Another function would be what? Protection. Right? Which organism is associated with Streptococcus pneumoniae? Here we discussed the R strain and the S strain. Right? Rough and smooth. Rough is the one that does not have it. Smooth is the one that has it. Right? Protection from drying. Okay? So protection from the immune system. Protection from drying. So these are the big things about the capsule. And then also I mentioned one more thing about capsular staining. You can stain the capsules either indirectly using India ink, which stains the background, so the halo is what's the capsule, or directly using ruthenium red. That's part of chapter 3 material. But any questions about the glycocalyx or capsule? Okay, so let's do the same thing, only in more detail for the cell wall, because the cell wall is probably the single most important topic. So let's do the same thing with the cell wall. So what are, first of all, the general features of the cell wall, right? Well, first of all, let's actually do it this way. Right? We talked about the bacterial cell walls and the archaeal cell walls. With the bacterial cell walls, what was common to them? They're made up of peptidoglycan, right? What is unique about peptidoglycan? It's made up of a sugar and a protein component. The sugar component is what? Is NAG, N-acetylglucosamine, linked to N-acetylmuramic acid. And the bond here is beta 1,4, right? That's the sugar component. And it has a string of amino acids attached to which one? NAG or NAB? NAB. To NAB. So you have amino acid 1, there's 4 of them. Amino acid 2, 3, and 4. Now for the final, this is a detail that you don't have to know. Is it D-ali or L-lysine, whatever. Just know there's 4 of them linked to NAB. Now this is common to all of them. What makes them rigid is the fact that 3 is linked to what? To 4 of another chain. So you have another chain, let's say, going up 3, 2, 1. Same thing. You have NAG here. You have NAG there. It's supposed to be a G. Another NAM, another NAG, you know, whatever. So you have a layer here, a layer there, 4 coming up, 4 coming down, 3 is connected to 4. Now, this is common to all bacteria that have a cell wall. What is different, for the most part, what is different is the gram-negative versus gram-positive, right? Gram-negative will have, and this is where, you know, like, let's put it to the side. First of all, any questions about this? So, then you might want to branch into, let's say here, gram-positive versus gram-negative. So what are, again, big differences? Gram-positive have a thick peptidoglycan. This one has a thin. This one is less complex. This one is more complex. Now why is this more complex than this? Because this one has what? Has the outer membrane. And I'll go into that in a second. But any questions? So what has the gram-positive got that the gram-negative doesn't? What structures do you remember? Starts with a T. Ends with Sorry?
Teichoic acid.
Teichoic acids, exactly. So that would be teichoic acid and lipoteichoic acid. Here, not. So how is this thin? It doesn't have teichoic acid, yet it is more complex because of this membrane, the outer membrane. So then you might want to go into the... But any questions about this? So then you might want to go into, again, a summary of the outer membrane. And here again, there's many branches. So gram-negative, we talked about the outer membrane. So you might want to, it has really 3 parts. Actually, it has many parts. There are many things associated with it. It has the LPS. It has the porins. It has adhesion sites. And it has lipoprotein, pairs, I'm sorry, a bronze lipoprotein. Bronze lipoprotein. So very quickly functions. Porins is for, they're called pores, so they allow things to come in. Adhesion sites are connections between the outer membrane and the inner membrane. So adhesion sites are connections. Bronze lipoproteins are connections between what and what? Between the peptidoglycan and the outer membrane. So these two are connectives. These are transport. This is the big one. LPS itself has 3 parts, right? It has the lipid A, it has the core, and it has the O antigen. The lipid A is the toxic component. The core is boring. I mean, there's nothing really good about it or interesting. The O antigen is the one that changes from one bacterium to another. So it allows it to resist the immune system. But if you were to able to, again, you might have a bigger or smaller paper to write on. But the idea is to try to, when you're studying, do something like this, and then that would, be what I'm going to ask you. What is this? What is that? So any questions about the gram-negative? Now there are exceptions. Actually, let's go over archaea real quick as we did. Archaea, 2 main types. First of all, well, let's go over the exceptions at the end. But with archaea, again, you do have 2 types of cell walls. You have the pseudopeptidoglycan, right? And then you have the S layer. So what's the difference? The pseudopeptidoglycan is similar to the peptidoglycan, but it's different. Oh, the one last thing about the cell wall is that it has unusual amino acids that are the D form, right? This is what peptidoglycan has. This one does not have unusual amino acids. So they're all L. That's not, so all L amino acids, so there's no D. It's beta 1,3, not beta 1,4. And it doesn't have NAT. It has NAT. And don't worry about what is NAT. NAT instead of NAT. Okay? So it has beta 1,3, NAT, and no D amino acids. If it has beta 1,3, it makes it insensitive to what? So this would be another connection. Well, I should have connected it earlier. The beta 1,4 is what is cleaved by lysozyme. And if it's gram-positive, lysozyme makes it a, and again, it's a long way back, but remember, PP. So gram-positive will become a protoplast. Gram-negative becomes a spheroplast. That's potentially 1 point right there. Lysozyme, which is found in tears, breaks gram-positive cell walls, makes them protoplasts. Breaks gram-negative cell walls, makes them spheroplasts. Okay? So this one has beta 1,3, so it's insensitive to lysozyme. Sorry? And then before I forget, those of you who came after I started, there's a sign-up sheet somewhere. So who has the sign-up sheet? Did anyone not sign this? Okay. So this is for their record. So can I please bring it, give it back? I mean, just hand it back, please. Okay, so, and the S layer is, S is for surface. So if you were to apply a gram stain to these 2, the gram-positive one would be the pseudopeptidoglycan, the gram-negative one would be the S layer. Right? So this one This one stays